The next segment of this section is about the graphs of trigonometric functions. So no new vocabulary or theorems here. Let's get moving on then to the first slide. When we graph trigonometric functions in the coordinate plane, we usually denote the independent variable by x instead of theta. So you can see on all the graphs here, and I'll draw one for instance here, we'll go with y and x rather than y and theta. It just makes more sense to use x and y on the graph. So here are the 6 basic trigonometric functions. We have cosine and we have sine. Those are pretty standard. And then we have tangent with, which you also may be familiar. Then we have the reciprocal functions below. We have the secant function and cosecant. And then we have the cotangent function down here. So this is figure 0.38, and it's actually on page 46 in your book if you wanted to take a look at this a little bit further. And it's good to keep in mind because not only does it give you the graph of those 6 functions, but it also will give you the domain, the range, and the period of each. And we'll talk more about period in a later video, but the domain and range might become important to you at some point with the trigonometric functions. So we're to our first exploration, and in this one we want to, I'm going to put quotes around here, unwrap. We want to unwrap a sine function. And so we're going to do this in a Desmos graph. And if you're following along in Google Slides, this is an active link. So I'm just going to say click here, and you can come to the same graph as what we're going to get to above. But here's the idea before we go to it. We're going to look at a graph where we have a unit circle already drawn. And so it's going to have a radius here of 1. And we're going to put an angle in standard position. And that means this radius is 1 as well. And so here would be the central angle. So we're going to think about this coordinate being an x comma y. And let's drop this diagonal, I'm sorry, this drop down the altitude, the perpendicular there, drop the altitude. And that means then that, I'm going to go to a different color, from the origin over to where that altitude dropped is x. And then from the line up to the point is the length of y. Now, if we think about this angle as being angle maybe x, or angle theta in this case, then the sine of that angle is going to be opposite y over hypotenuse 1. So essentially the y value here is the sine of the angle. And we're going to use that idea to kind of generate the graph of the sine. So let's take a look at this Desmos graph. So when you click on that link from Google Slides, this is where you will be. And we see the unit circle here. And we see the x-axis labeled in multiples of pi over 2. We see the radius of that circle 1. It is a unit circle. And we are going to drag through the slider of RAD, radian. So what that's going to do is stand for the length or the measure of the central angle. So let's take out radians to 1 and stop it there and see what's going on. So here is that point that I drew on the previous slide, and in blue here is the y value, which again we were talking about being the sine of this interior angle. And then generated as we drug rad along was a purple curve, and it's starting to move out. But notice that the y values of that purple curve are the exact same as the y values where we have the interior angle in the unit circle. So as we drag along, we'll go back to 2 a little bit more. What's happening here? Let's see, a little bit more. Stop at 2. So as that y value, again, that's the sine of the angle, goes all the way up to 1, then the curve is starting to be generated here. And then here we are past 1, so now it's getting a little bit smaller and we're curving down. And again, it's just the y value of that point as it travels along the unit circle, and that's where we are generating or unwrapping the sine curve from the unit circle. And here we are with 1 full rotation around the x-axis, and we can see the sine curve has begun. And as we move further around, we're going around the circle one more time, this curve comes out again, but it is being generated by the sine of that angle, and that's because the sine is just the y value of that point. So feel free to play around with this a little bit. You can also make the circle bigger if you want to. And so we could come out and have like a circle of radius, maybe 2, and we can see that the sine curve gets a little bit taller because it is all depending on the y value of that point around the circle. So have fun with that. And that's about our stopping point for this video.